Good evening. This is Professor David J. De Los Reyes. My topic for tonight will be exact differential equation. This is now lesson number 31 on my course differential equation. This is topic number 31 and this is actually exact differential equation. Okay, let's proceed. This is lesson DE31 under the topic differential equation, subtopic exact differential equation. We are now through with the variable separable. We are now through with the homogeneous. We are now through with the Bernoulli's equation. We are now through with the differential equation that could be solved by using integrating factor. So actually this is the fifth topic under differential equation, the solution of an exact differential equation. Okay, let's proceed. The form of the differential equation will be something like this. M as a function of x and y times dx plus n as a function of x and y times dy equal to 0. The form is something like this. How could we say if this differential equation is an exact differential equation? I place it here. If the partial derivative of m with respect to y is equal to the partial derivative of n, sorry for this one, syntax error guys, this should be n. Partial derivative of n with respect to x. If these two here are exact, we could say that the given differential equation is an exact differential equation. That's the so-called sign for it to be an exact differential equation. If you take the derivative or partial derivative of m with respect to y, and this is equal to the partial derivative of n with respect to x, the given differential equation is an exact differential equation. While we are taking the partial derivative of m with respect to y, treat x as constant. And also for this one, while taking the partial derivative of n with respect to x, treat also y as constant. Okay? So after taking the partial derivative of n with respect to y and n with respect to x, and it will be equal, the given differential equation is an exact differential equation. Okay? Let's try to bring out the proper concept on how to solve this exact differential equation. I summarize the sequence. Number 1, expand. Expand the resulting differential equation. After the so-called expansion, okay, there are terms which are directly integrable, di, meaning there are now terms that could be integrated directly. So di, directly integrable. So under step number 2, integrate the directly integrables, because after the expansion, whether we like it or not, there are terms which are directly integrable. And for those not directly integrable, that is step number 3. Those not directly integrable, the solution is something like this. There are two solutions. It will be the integral of m dx plus c equal to 0. For the meantime, while you are integrating the integral of m dx, treat any y as constant. Or the second solution for those not directly integrable, it is the integral of n dy. While taking the integral of n dy, treat any x term as constant. Meaning, you could bring it out from the integral sign. That's the meaning of this. So the general solution for an exact differential equation, the total general solution now, because there are two terms. directly integrable and those not directly integrable. Okay? So to take the total general solution, just take the sum of these. So the general solution of the given exact differential equation will be the integral of those directly integrables plus the integral of m dx plus c equal to 0. Or as a second solution, it will be the integral of those directly integrables plus the integral of m dy plus c equal to 0. I presented two solutions here, and it should be the same solution. Meaning, if you try to use the first one, okay, that is still the correct solution, plus this. And if you use the integral of m dy plus c, what will come out for these two here will be the same. Okay, that's the meaning of that. Okay, I place a note here, and this, try to memorize this by heart. That is, the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. If these two here are exact, the given equation is an exact differential equation. That's why our topic for tonight is the solution of an exact differential equation. That's it, guys. For tonight, I just discussed the concepts on how to attack a problem regarding exact differential equation. I give you the form and I give you the proper steps on how to bring out the proper solution. So the next time around, it will be topic DE32. I will now try to give you an evaluation problems on how to solve an exact differential equation. Example problems the next time around. Okay. For those who are taking up differential equation, this is for you guys. So if you want to learn something from me, okay, try to follow my channel maybe. That is Professor David J. De Los Reyes at youtube.com. If you want to subscribe, you can click subscribe. Oh, good evening, Los Angeles.